Yeah, hello there and welcome to the Developer's Guide to Windows 10. I'm Andy Wigley and with me got Shen Chauhan. Yeah, hi. So we're in the Developer Evangelism team here at Microsoft. This is day 2, if you're watching this live, of the this new update to the Developer's Guide, our MVA material, which this update is around the build 10.2.40 release, the first public release of the Windows 10 Universal Windows Platform. Yeah. So if you're following this live, the agenda has changed a little bit. So this session XAML data binding. It's a bit early for me. Yeah. XAML data binding was meant to be yesterday. We shifted it through. We're going to start with that one this morning, and then the rest of today, if you're going to be following with us live, we've got some awesome content such as Cortana, inking, and voice commands, and loads on tiles and notifications. We've got
we've got the store, so you'll have to like sort of get your lovely app and push it out. And
that's right. So the whole store story, because this is some of the new content that we've now got. The store is open for UWP apps to be submitted. So we're going to take you through that story. We're going to talk about background tasks and a bunch of other stuff. So there's a lot of great content for you today. Oh yeah, app services and app-to-app communication. So
my favourite.
Yeah, loads of great stuff, and hope to get you really excited about building apps for Windows 10 on the Universal Windows Platform. So this one today, we're going to start with talking about data binding. Doesn't sound terribly exciting, does it?
I think there's loads of really good content here, like data binding, especially with some of the new stuff coming up. I think it will change the way people start thinking about applications.
Well, that's the thing. So what we're going to cover now in this session, we're going to look at, we're going to be looking at, first of all, an introduction to data binding and what it is, just at a very brief level. And then we're obviously going to look at this new feature, which is compiled bindings, which is a great performance improvement for data binding. So first of all, let's just have a look at the basics of data binding. So obviously, if you think about a little block of XAML like that, you can put a text block and you can actually either put it as the enclosed, the content of the element there, or you could say text equals hello world. So you could hard code this kind of stuff directly into the XAML, or you could sort of set it in code. And yeah, sure, you get the the required result comes on the screen, and that's fine for a hello world. That's really for any kind of real application. That's going to be no use at all.
If you're going to try and localize this, that would be a bit of a challenge.
Yeah, localization is one thing, yes, which actually we don't talk about. So in this MVA we really should. So hard coding stuff like that. But I mean, obviously most apps are running against collections of data, and by their very necessity, that data is going to be changing. What use is an app that just shows you hello world every time you run it? Some people might get excited by that, but I don't. So yeah, so clearly we need something much more flexible than that. So the way that we actually do this in reality is to, well, actually the other one we didn't talk about, you could actually in your code behind set the text properties directly, but that's essentially exactly the same.
Like the XAML does that in the background anyway.
That's right, exactly. So, but no, this is the way that actually, really should go about things, and that is, you would have the data for your app is encapsulated in a class sometimes. Now, in simple apps, you could put that actually in the page class, in the code behind, but that's not a good model either. If you're going to do good software engineering practice, it's good to have separation of concerns and have different objects that do different things. So you can have your XAML page is about presentation, but really it's better to have the data, the state of your application encapsulated in another class, and we call that a view model.
So the whole weak coupling, strong cohesion type thing.
That's right. So the MVVM pattern, model view model, this is a key part of that. So you typically would have, you need to attach an instance of your view model class, which is just a data class. I mean, it throws some events. We'll talk about that in a moment. But you basically got to connect an instance of your view model class to your view, to the XAML page. And one way you could do that is just new one up in your constructor, and then with classic data binding, every framework element has a property called data context. And when you set data context,
so that's that guy there.
There it is, yes. when you set data context, you're establishing the context for data binding, the object where it gets its data from.
And so for people that aren't familiar with MVVM, I'm assuming like if they're familiar with the web and they do MVC, it's sort of like MVC but for XAML-based applications, right? It's
Yes,
a
very similar
approach.
pattern.
Yeah.
Yeah, similar thing, yeah. Now, yeah, so you could actually have in code in your code behind on this page. You could have in your on Navigator 2, you know, var VM equals new my view model, and then you could say, well, this stack panel hasn't got a name.
Whatever the
so
name
it
is.
says if it had an x colon name equals my stack panel, then in the code behind you could have my stack panel dot data context equals VM, and that would achieve the same thing. But this is actually a nice pattern, and it's one that is often used. This in the resources block there on this XAML page, what that statement inside there is actually saying is, create me an instance of this class called viewModel, and local colon is the namespace, so the namespace of the class, and namespace symbol. So you're saying, create me a new symbol, a new instance of this viewModel, and give it a lookup key of VM.
So it's similar to the C# equivalent of var VM equals new viewModel.
That's a good way of putting it, yeah. And then down here, data context equals, whenever you see static resource, for people who are not too familiar with XAML, it uses the thing after the static resource as a lookup key for anywhere the page resources first, then your app resources, it goes off and looks for a resource with that key name. Okay. So here, that VM is matching up. Oh, okay, I see. You mean an instance of that viewModel class. So that's kind of, that's making that connection. Now what about this binding message here and binding button text? What's all that?
So I'm assuming that's basically reading of properties on your viewModel or your data context, I suppose. And message is probably something that you're going to have here on your VM viewModel.
So that's exactly right. So when you see a binding statement like that, it's just doing a lookup for properties on this viewModel class, one called message and one from button text, and it's pulling the content back from it.
And this happens at runtime?
And this happens at runtime. It's a reflection based, and it's not, in a sense, you could say that this is the way we've done data binding forever, and it's super flexible, and it's a great way of having that observer pattern thing going on between your view and the view model. So there's no code. The view model class doesn't actually ever sort of directly set properties. It doesn't know who's consuming its data. So it's all very much declared here, saying, okay, I'm interested in the message and the button text properties of this class that happens to be an instance of viewModel. But
so you've got like a nice layer of abstraction between the two.
That's right. So it's classical decoupling. The view knows about the view model and is pulling data out of it, but the view model has no concept of who's consuming what it's doing.
And that's great for code reuse.
It is great for code reuse and great for flexibility. So there's a key part as well of classic data binding, in that there are three modes of data binding and binding statements. So in classical data binding, the default mode is one way.
One way, yeah.
So there are three. There's
one time, and two way.
Yeah, one time, one way, and two way. So one time means that when the page is first displayed, the binding statements will go just one time, as the name suggests, off to whatever the data context is. We'll pull the values away, get the values of the properties that are named in the binding statements, use them in the XAML and display them on the screen. But thereafter, there's no further connection with that view model.
So any changes that I make actually will never get reflected on the UI.
No, that's right. So in a view model class, you implement this interface called iNotifyPropertyChanged. And basically what that has is just an event. Now, when you have a binding statement where the mode is equal to one way, which you said is the default, every time a property value in the view model changes, it basically fires this notify property changed event. And that is the trigger for the XAML to say, oh, that property's changed, I'll go off and get the new value. So any changes in the view model are always automatically reflected in the view.
Okay.
And then the two-way actually it does both ways, as the name suggests. So not only when properties values change in the view model does the view get updated, but when somebody types into or control or select something that's data bound to a property in the in the view model, it will write those changes back. So you get this two-way communication going on.
So one way is from C# to XAML, and two ways C# to XAML and back from XAML to C#.
Exactly,
so you cause a setter on that property too.
That's right. Yeah, and it's all this iNotify property changed interface, which actually is just this event. And there's a pattern for writing view models. For whenever a property in the setter changes, you fire this property changed event. And then there's a complementary interface called iNotify collection changed, which does the same but for collections of objects, like an observable collection of some type of data object, and that fires events to whoever is interested whenever the oh, there we go. So I have to turn my notifications off.
So what we're really saying is, so with the iNotify collection changed, I mean, do people generally implement that, or are you pretty good in just using the already implemented observable collection or read-only?
Observable collection automatically has that support built in. Yeah, so yeah, that's kind of built in. So if you're doing a custom collection, then you kind of start having to worry about this.
It's a bit more niche, I suppose.
But most of the time, this is why you see these observable collections everywhere, because they're absolutely perfect collection for bindable objects. Let me just turn that off. Cancel. Turn on quiet hours. There we go.
Sorry, people, we're turning you down.
Yeah. All right, we're back on. Okay, yeah. So that's the kind of plumbing. There's also an interesting thing as well, just I'm not going to go into detail on this, but there's also this nice ability now, which WPF developers have had for a while, and there's been various other implementations, but now you can actually, on a dependency property, on a class, you can register for an arbitrary property changes on an object.
Oh.
So you can get notified for a specific, if you're kind of interested in, this is kind of what the XAML does, you can be interested in the value of a property changing on say, a view model in code from another observer, you can actually register directly for changes in that. So.
Which is quite nice, because I think before you just could only wire up to the property change event, and you just get
you'd have to filter it.
You just get everything. It'd just be so much of an event store.
So that iNotify property change, what it actually does is it fires this property changed event, but in it is the kind of the name of the property that has changed. So if you're kind of if you're doing what XAML does and interested in changes in properties of some class, you'd have to just hook the property changed event on it and then do a switch on the property name to say, is that the one I'm interested in? No, not interested in that one.
Normally wouldn't be a good thing to do.
Oh, there we go. So now you can actually specifically wire it up, so that's good. Okay, so this is the full options, all the properties you've got on a binding statement. All looks rather scary. So there's a lot of stuff in there. I mean, the key ones, the mode we talked about, that's the one-time, one-way, two-way.
Two-way, yeah.
Target null value is just if when it goes to try and get the value, it finds the target null value, you can supply a string to display, saying not found or whatever it is you want to do. Yeah.
What about path? Because that seems like it's going to be kind of popular, but you don't normally see it in your.
No, that's right. So you don't really see it, because when you say the binding, the path is the kind of the default properties. So actually, in the previous example, when you said binding title or something, what we're actually saying is binding path equals title. So that's the default property. Yeah. So that's the path through to actually drill down to the property value you actually want. If you think about a view model class, it could expose kind of discrete properties like title, name, first name, whatever, as top level properties of that object, in which case you just say binding first name. But it could have it, the view model could expose. The view model could expose an actual object, which itself is a person object, which has a .name, .first name. So you can actually drill down the properties. Yeah.
Yeah, because I was going to say, if you use element name, then chances are you're saying I want to actually bind to a property based on this element name, and then you'd use your path then to be more explicit, right? Yeah,
that's right. Yes, yeah. These ones are interesting as well. The converter thing. So. There's a kind of implied thing with binding statements that the property that you are binding to actually gives a value that can be easily converted to string. Because obviously XAML is just displaying strings on the screen for these values. But some things are more complicated than that. You can actually bind to a
maybe like a datetime object.
Datetime object
is a good one.
And you just get the default to string,
which is like
which is not probably what you want. So you can use actually a little converter class to actually convert the value that you read out of the data of the view model and convert it into a slightly different, exactly the format you want to display on the screen.
So it's like an interception between the binding, and then essentially that's reusable, right?
Yep.
This converter, so you could use it in many different places.
Yep.
Yeah,
That's right. And then this one is also interesting, update source trigger. What is this one? So this one is saying, okay, when the user is interacting with the view, what's the trigger for causing that to then go and update the view model?
Mm-hmm.
And normally it's just, if you use a selector, selects a value in a drop-down list or something. Then it's just the property changed is what causes it.
So when would I use this one then? I mean,
The classic one for that is with a text box.
Yeah, because that doesn't fire when you're typing into, right?
It doesn't. You're typing in all these statements. You're typing into it, and nothing's happening until the text box loses focus. So if you want to continuously update the actual, and that's just the default that's set on that control. Mm-hmm. So, but if you want to have it update the view model on every character, then you can set update source trigger equals property changed, and that'll do that. So lots of things. There's a bit more about these converters. So you just have a little class which its job is to convert from one format to another during binding statements. So it implements an interface called iValueConverter, which just has two methods in it: convert and convert back. You often don't see convert back implemented because effectively convert is when you're doing one-time or one-way binding, so the data is flowing from your view model into your XAML view. And convert back is only when you've got two-way data binding and it's going back the other way, which you don't always want to do. So so that's that. Let's just do a little quick demo of the classic binding. Where are we? Here we go. Right, so here I've got a sort of bit of a starter project, and we're using kind of, a nod to proper architecture here. So I've got a model class. This is my basic data item, which has one property.
Title.
Title, yes. So we're not getting too ambitious here. So just got one property called title, and also we've got a view model, main page view model class, which actually exposes a collection of these to-do items. So you can see that actually its property.
A lot there.
Yeah, so actually this property called items is an observable collection of to-do items.
Okay.
So this is this collection which automatically fires these iNotify collection changed events. And this one is, here we're doing, we're just creating 100 of these to-do items and giving them task title from 0 to 99, and we're adding those to the collection. So that's my raw data for this.
Okay.
Now over here in my main page.xaml, actually in the back of it, I've got something. Actually, let's put that. I want to come back to those. Let's comment those out for now. So actually at the moment it's just nothing. It just says initialize component. But over here in my XAML, this is where we've set the data context of the page to what we've got is that VM is this symbol here. VM is using data binding sample.viewModels, so that's referring to an object in the viewModels namespace. And obviously what we're doing is getting an instance of that main page view model, which is in data binding sample.viewModels.mainPageViewModel.
Yeah, makes sense.
So here we go, and the UI is empty at the moment, as you can see. And what I want to do is just display a list of all of those objects. So let's go ahead and do that. Let's just scroll this up a bit. First of all, the main grid, I'm going to just create myself a couple of column definitions.
Create yourself one of those Andy Wigley special user interfaces.
Yeah, I'm going to excel myself this time. I'm going to create some columns because I want to have two columns, because what we're going to do with this is compare classic binding with compiled binding. We're going to have a column definition in here. Cool. And actually, I'm just going to have that as a star. And
so people that probably saw previous sessions will sort of understand what's going on here.
That's right. So we've got two columns now up in our UI up here. You can see equally sized, 1 star and 1 star, because I haven't actually explicitly exposed. And so down here, I'm actually now in column 0. I'm going to create me a list view so we can actually look at all of these things. We'll put a header on it so that we've got, we can actually see what is this is classic binding, and we're going to have an items source. This is where it gets its object from.
So this is saying this is the collection that I want to show in this control.
This is saying where is my collection of objects, and here I'm going to use a binding statement. So it's going to go off to that data context.
Yeah.
and we're going to look for a property on there that has a collection of objects. Now, if you remember, there was only one property on there, which is called items.
Which is nice, because you're actually getting it in IntelliSense.
Yeah, there you go. So it's actually drilling down, because we've set the data context already, you're getting that in IntelliSense, so that's really good. And it's already, we don't have to specify which column it's going in, because by default it goes into 0. So at the moment, that's kind of interesting. At the moment, the kind of design time data is already picking up, but all it can do is take the type of the object in this items collection and do a toString on it. So you just get the name of it coming up by default.
Which isn't very useful, I suppose, for the user anyway.
Well, no, not terribly good. So even by the standards of my my UIs, that's really not very useful. So actually, what we want to do is create ourselves an item template. So that this is we're now going to format how each item in that list is going to be displayed, and that has to contain a data template. This is, and inside this we actually define what is the XAML we're going to use to display every item.
So so every item will now basically use this template to then decide how it's going to look. So you've got a text block in there.
Text equals, then here again we're going to use another binding statement. So we've got binding, and then we need a property on a to-do item, which is, again, title is coming up in the IntelliSense.
So essentially what we're doing is on the list view, we're saying we want to say the items. Then when we're doing our data template, we essentially just take that one object and say, right, okay, well, in an item, we know we've got a title property. So it's not a property on the collection, but it's a property on the actual individual item that the collection is.
The collection of items, it's one of these. And then that just repeats for every item in it. And actually, you can see even in design time, it's come up with task title equals 2. And of course, you won't be surprised to know that if we run this, then we get our list out very nicely in a minute. Actually, it's not going to do anything different from the design time experience, but
there we go.
Whoa!
Had a nice animation.
Best demo I've ever written. I'm really on fire today. There we go. So that's the kind of very simple introduction to that's one-way data binding. There's no iNotify property changed in the individual items. We haven't got any logic change in that, but that's a good introduction to the basics of that. So that was classic binding. And you can data bind to models or data. You can actually data bind to elements on other elements on the page as well.
So you don't even need code behind at that point. You can just point it to another element and.
No, that's right. So actually, let's do another demo. But this time I'm going to do one with the to the element name. Okay, so
Oh.
What's the one to get back again?
Try Control Alt and then the arrow up. Or down.
Oh. No. So what? Now I'll go up. Thank you.
Go.
I have all these buttons.
Control
the wrong
Windows.
Buttons are right next to each other on his laptop.
Yes, laptop manufacturers have different sets of keys at the bottom. It sometimes confuses me as they swap brands. Yeah.
I'm always very nervous whenever I do this because this happened to me before.
Virtual desktops is essentially.
I'm picking up a new laptop tomorrow, so there's nothing wrong with this, but the keys are just wrong next to each other in the wrong place for me.
You go on autopilot.
No. Now I need to keep that one actually. So let's have a new instance of Visual Studio up, and we'll just do a new project for this one. Just to show you kind of how this works.
So I use element name binding quite a bit sometimes. I find it really useful. It just keeps my view models very clean as well when I know I can get the information from the parts of the design.
Yeah. And we're now demonstrating the blue swirly donut.
It's an optional extra, this one.
Yeah.
Yeah.
It's good, isn't it? Yeah, so data binding to elements. I don't know what this is doing. We got into a bit of a.
It's because you flipped the screen round.
Yeah, it's upset like I was. Yeah, so we'll just wait for that to come back. Data binding elements. So the idea here is you've got a load of XAML elements on the page, and you could have one of the elements is data bound to your data source, but then other elements could be actually data bound to the elements.
So we actually use element name binding when we were talking about the split view, for instance.
Yeah.
We actually used element name to say, actually, I want the button to be the same width as the actual compact view, the compact pane length. And the nice thing about that was I didn't have to worry about writing in any C# to sort of do the matching. I could just say element name is this, property is compact length, and then from there it would just work out. How wide it needs to be. So if there's any change on the parent, at least the child will then work itself out.
Yeah,
which is quite nice.
This is not coming back. I've got a Visual Studio crash on me. That's not good.
All right. Failing that, it's see if you can kill it.
Yeah. Doesn't want to know. Ah, that's disappointing.
Control Shift Escape if worst comes to worst.
What is that?
Task Manager. Oh, there you go. A polite little threat, and it came back to life.
Okay. Well, it's not quite back to life. Let's just close that. And let's, Shall I start again? Do you think that might?
Yeah, I think so.
Might be better.
Be
Tell you what, I'll do File New Project. This one's working. Let's do a new project in here. I can go back to that data binding sample before. Right. Okay, let's try that. This is better. Why did I just start a new instance? I thought, well, what could possibly go wrong?
App 3 was never a good name.
It was never a good one.
App 4 is way better.
App 4 is the way to go.
It's the new version.
Yeah.
Okay.
All right. So there we go. And actually, you know, after all that, this is even is going to be an even more stunning UI. So let's have a stack panel.
Mm-hmm.
And let's put it in the center of the page. So we're going to have a horizontal alignment equals center, and a vertical alignment is equal to, not surprisingly, center. That's good for our container of my UI. And then in here, let's create ourselves a rectangle. We'll make that a width of 100 and a height of 100. And we'll fill it with a nice colour. What colour would you like?
Lawn green. I always think if your lawn looks this colour,
okay,
you've probably got something to worry about.
All right, good.
Yeah.
Okay, let's put a margin of it of 50 as well, so we've got a bit of space around it. So that's our rectangle. That's all very good. Oops. Very nice. So up here somewhere we should have a lovely lawn green rectangle. Oh, 100. That's a bit. Let's go a bit smaller. 50. There we go.
There you go. See, if your lawn
There
looks
we
that
are.
colour.
It's
got a
not
bit
well,
of
is it?
radioactive lawn.
That's right. Yeah, that's an interesting name. And I'm going to put a slider on here as well. A slider control. So it's just as the name suggests, a slider. A minimum value on our slider of 0.5. A maximum of let's say 2, and a step frequency, so the step as you scroll it, of 0.1, and actually I'm going to give it a name because I'm going to refer to it, call it my slider.
So step frequency is similar to the increment really every time.
That's right, exactly right. So there's our slider underneath now. You've got a little slider thing you can slide across.
It's got the new style.
Yeah. Now, what I'm going to do here is actually I'm going to put a binding so that we are binding. I'm going to put a scale transform on it. So you can actually change the size of our rectangle, but based on the value, of the slider.
Oh, right, okay. So we can make the lawn larger or smaller.
Yeah, that's right. So we're going to transforms down here. And we'll select this one's the scale transform, and I'm going to hit this little button here, and I could code this, but I'm going to actually create a data binding. This is the data binding wizard, so it's just another way of doing it. And normally, obviously, default is data bind to a data source, but actually I'm going to go and off to an element name. So we can drill down, find our element. There's my slider, and then you see all the properties of slider over here. So, and loads of them inherits from, all the way of the tree and this sort of thing. But down here is its value. There we are.
There you go. It's a double.
It's a double. There's no value converter. You can hook up value converters here as well. And then that has actually put my scale X is on there. And actually I'm just going to copy that.
And you could do this in Blend as well, right? You don't have to use Visual Studio to do
Yeah, absolutely, you could. And I'm going to do both of them, scale Y. So now I'm going to scale that, scale this thing based on the value of my slider, and it will change the scale of the rectangle. So that's just a simple sort of example of this kind of thing. Here it comes.
All right.
And now, as we make it bigger, there we go. Our rectangle is automatically bound to the value of that. So that's a fun example, but you can see you can actually bind all sorts of things to other elements. So there you go. All right. Now try this magic key sequence again. Control. See, I can do it.
Yeah.
Right. So that was binding to elements. Now then, let's talk about the new guy, compiled binding. This is really exciting. So, because the thing about classic binding is it's super flexible and it encourages this nice architecture. You've got good separation between your data classes, your view models, and your UI. That's all great and it's all good, and it allows you to create maintainable apps and not have loads of horrible spaghetti plumbing code. So it's just a nice pattern. But its very strength is also its greatest weakness, if you like, because in terms of the raw performance of your app, it's a weak link. Yeah, there's an overhead because it's this binding statement. It's just got these names on it. So there's this idea of this thing called duck typing. So you know, we had a statement, an example on the earlier slide where it's binding to what was it, title, and I forget what the other one. But basically, here we've got title in this one. Essentially, it means you could data bind to any object that has a property called title, and that binding statement will work. So, in this example, duck typing means, you know, if it sounds like a duck and looks like a duck and walks like a duck, it's a duck. But it could actually be an elephant, but it just happens to have a title called a property called title. So, that's flexibility is very good. But it has to do with, it has to discover these properties through reflection, and there's a cost on that at runtime. So. You talked yesterday about XDefer, which is one important deferred loading, which is an important new feature we've got in XAML for only loading things into the visual tree when they're needed. But this is another one of these great new features we've got in XAML that is really going to improve performance. So introducing compiled binding. This is a brand new mechanism for data binding. Well, it's an incremental improvement. It's not like, you know, you can actually, it's a drop-in replacement for classic binding.
It's like a V2.
So the idea is, how do we keep the power of binding but make it faster? So the way is you actually make it compiled rather than...
so it's no longer runtime.
Yeah. So what happens now is, instead of at runtime, you're doing the wiring up and everything is all done at compile time. So with xbind statements, it looks at what it is and actually does it. The code generator in the background is generating C# code to actually do the property change monitoring and the moving the stuff backwards and forwards. So it eliminates this need for slow runtime reflection, and it also gives you improved ability to inspect and debug. So, and it also, you get a compile time validation of your bindings, because the other thing with classic binding is if you spell the name of that name wrong,
you'll never know.
No, and actually you didn't even get anything at runtime. It doesn't throw an exception. It doesn't throw an exception.
Quietly.
You get something. You get in the output window. You'll see when a binding expression can't be worked out. But now you won't get past the compile stage with xbind, so it's much more solid. So yeah, this is the kind of problem with classic binding, if you like. This graph shows CPU usage of admittedly, it's a carefully crafted sample to make sure that it's
trying to illustrate the point.
Yeah. So we got all that CPU, massive CPU, in order. This is it resolving all its binding statements, and it's over time. This is the CPU effort on a particular sample that we've got with loads of elements on it. And then if you compare that with exactly the same sample but using compiled binding, well, that speaks for itself, doesn't it? So now you've just got this little peak here. The time is minimal by comparison. It's
I mean, like it's going 9.5 seconds to 9.6. So well, not even 9.6. Pretty short.
Yeah, it's not even 10. Not even 10 milliseconds, is it? And then up here we're like way out. It also happens earlier on the timeline. People watching this won't be able to see, but the classic binding starts at nearly 12.35 seconds. This one starts at just over 9.5 seconds. So then it's over. It's done by 9.6.
So we're sort of saying it's faster and more reliable in terms of a developer experience.
Another way of looking at it, the memory usage as well. So this is an example of two side by side with a sample that's, well, it says 1,600 borders with their background data bouncer. Not exactly a typical example, but it illustrates very nicely.
You never know.
No, that's right.
You never know.
Obviously, the shortest way is no bindings at all, so just rendering the XAML page. And so no bindings is the bottom block there. So that's the same for both, of course. And then we've got an example of some elements doing one-time binding.
Using XBind.
And
right.
there's XBind one time is the first low one, and then it's the same thing but using classic binding one time is there. You can see the memory usage is goes from like nearly 5 megs with XBind right up to 10 megs of memory usage for classic binding. Then you've got the same thing with one-way, and we've got a bunch of stuff that's done one-way binding, and that one again is it's getting up to about 5.5 megs with XBind, and with classic binding you're looking at getting near to 12.
Yeah.
So yeah, you get real improvements right the way across the board with this. So it's compiled binding, strongly typed. Duck binding is not supported, so it will be all your binding statements are resolved at compile time. Now here's one change, okay? We were saying before with classic binding, the default is one way.
Yes.
Now, not with XBind. So this is one thing, if you're doing a kind of drop-in replacement, might trip you up. So the default now is one time. So if just remind you, the one time means that when you first display the page, it will go off and it will pull the values out of your view model. But then if your view model changes due to other logic that's running, whatever, you will not see that reflected in your UI. So if you want one-way data binding, and this is a performance step, that we've done this deliberately, if you really want one-way binding, that shouldn't be the default, you're going to ask for it.
Yeah.
Makes sense.
Which makes sense, because most people actually, once they're bound to an object, it's just like a one-time anyway.
Yeah. And the beauty of this is it doesn't change your view model classes. So the classic engines that fire data binding, I notify property changed, I notify collection changed, and one we didn't mention before, observable vector, which is the C++ kind of one.
Yeah.
Those all work. You don't have to change your backend at all. So all you're doing is changing the XAML page, and the view models just carry on working just the way they ever did.
And that's because we've got that separation of concern as well.
Exactly,
which is
the nice
nice
separation of concern. It's a great example. Yeah, yeah. So yeah, so now here's also the change. So we said that with classic binding, you set the binding context for a framework element, typically the page, but you can set it at any element by setting the data context property of that object.
Yeah.
The data context property isn't involved anymore with XBind.
Oh, right.
We've got a pattern later on where you can actually kind of still carry on using it and it will just work. So I'll show you that later on. But the data context where binding statements are resolved against is actually the page class itself. We talk about the code behind class, but a lot of people don't realize that actually a XAML page with all the XAML or XML on it and its code behind, they're actually the same object.
Yeah, it's a partial, isn't it?
Yeah, so all that the XAML is a declarative way of saying, new me up a grid and put in inside a child collection, new up a stack panel, and inside that put a text box. You could actually create a whole XAML page entirely in code. But you'd be crazy.
Yeah.
So that's why we have XAML. But whenever any binding statements you have with XBind, the path that you're specifying is the class itself.
The actual class itself.
Yeah. So that's a little bit different. Now, just to compare the two, that's classic binding. This is XBind. As you can see, all you do is you drop in XBind. And all the properties are exactly the same. Your converters are the same. Fallback value mode and path are the same. Target null value is the same. A few of these are not there. So element name is not there. Now, that's because it's not necessary. Because actually, if you think about my slider, my slider, if you give it a name like that, is a property of your page already.
Yeah, true.
So if you remember, we're saying the data context for XBind is the page class.
Itself,
so if you want a data bind, do an XBind version of that demo I just showed, well, easy. You just XBind to my slider.value.
Yeah. So
easy.
Makes sense.
Yep. And these relative
Makes
source and these
sense again.
they don't make sense anymore. And update source trigger is not there, which is a bit more of a problem. So yeah, that's kind of one case where you might want to retain classic binding, I think. Yeah, so they're not there. I was talking about them. Now, here's also a change as well. So, taking our example before, the list view item source equals xbind view model. So now we're looking for a property on our page class called view model, and that has a child property of that called employees. So employees is now our new collection for this list view. Now, inside a data template, you then obviously, in the same way we did classic binding, you're then binding against a property of the individual data object inside that collection.
Yep.
So here we are binding against the name property of a single employee, and then this repeats obviously for every employee in the collection. But with data templates, you've got
to have a data type.
You've got to specify the data type on it. So you put X:\data type is necessary, and actually if you don't do it, the compiler will tell you need to do it.
Okay, so you get all the necessary warnings,
yeah,
and
so
it gives you a very clear indication as to what the problem is.
It's not like something you're going to forget because it won't compile. So, but you have got you've got to tell it what the data type is. So, okay, you've told it up there. Okay, I'm binding to a collection of objects called viewModel.employees, and that is an observable collection of employee presumably. But inside the data template, when it compiles, you've got to actually tell it, okay, this data template is referring to a single employee. So you've got to do that.
Okay.
And then you can just data bind against a property of that employee object. Right, let's rework that example before, but using compiled binding.
Okay.
Right, file, recent file projects and solutions, data binding sample. Here we go. So here we go. Now then.
So this is your list view example.
Yes, let's create ourselves. Let's tidy this up, and let's just copy that. And this time, I'm going to use compiled binding. And this one I'm going to put into grid.column equals 1. So that's going to go over to the right, so we can do side by side. Yep. At the moment, we're still using classic binding, of course. So we've got item source equals binding items. And I'm going to change this to an xbind.
Yeah.
Items. Okay. So let's just try and compile that and see what happens.
So we're expecting this to fail, right?
I'm expecting this to fail. Yeah, because we haven't actually
done the data type.
We haven't got a property called.
Yeah.
There we are. Invalid binding path items. Property items can't be found on type main page. So it's looking for a property called items.
Yeah.
It's in the view model, which we haven't actually declared as a property of our class as yet. So, you know, one thing I could do, what I will do is declare a property on my page called viewModel of type main page viewModel. And then, you know, one thing I could do in here, and I'll do it actually now, is just in my constructor here, I could say viewModel is equal to a new viewModels.mainPage viewModel.
Understood. Yeah.
So we've created an instance of our viewModel and we've plugged it into this property. Now over here on on the page, the property is not called items; it's actually viewModel.items.
Yeah, because you're taking that property and then you're taking a property on the property.
Yeah,
that
so,
makes sense.
Yeah, that's right. So yeah, exactly. So viewModel is the top level property here. And that is what we're drilling down to is a property of this main page viewModel, which is items.
Items, yep.
Yeah. So that should now compile. Yep. And actually, if we remove just temporarily remove the classic binding, I'll put it back in a minute, and remove the declarative way of creating that data context, then this will work just great in pure compiled bind. This is a purely compiled binding one. There's nothing stopping you in a UI combining both. So there's our compiled binding, and everything's come up.
So it's
but if you're combining both, you've still got to obviously set the data context for your classic binding.
So it's interesting you didn't have to set the data type there, I noticed.
Well, that is interesting, isn't it? That is interesting. So that means actually we're not getting the full efficiency of this. Yeah. So so it's used. What has happened is that we've bound the X bound to the data collection, so it's generated nice code to go and do that in a very efficient way. But then inside here we're down back to duck typing. It's going classic binding. It's saying, I'm just going to go and get a title. So actually, if we want to get real true efficiency, then of course what we want to do is X bind to title. That's what we'd like to do. And actually, if we build that,
they're going to build.
It will say,
they'll give you a
no data type defined for data template.
Yep.
Templates containing X bind need a data type to be specified.
Yep. Okay.
So we can actually declare our namespace anywhere, but let's put it in here. XML and S.
So that's XML
colon,
namespace.
and then let's call it M, a namespace, is equal to, and then we need to go off to our dating binding sample.model. So this is the individual items are.
So that's the namespace of the actual item itself.
Yeah, that's right. And then this statement actually goes on to.
So then you do like
goes on to the data template statement. So this is where you have to put X colon
data type.
Data type is offered there in IntelliSense.
Then it should be M something, I'm assuming.
M colon, and then it's a it's a to-do item, isn't it?
Yes.
Is the name of the class. So now we're drilling down into this guy, a data binding sample.models.to-do item. So now this should just work.
And now we're getting the whole power of compile time binding across.
This is purely compiled. Everything is compiled binding on this. Yeah. I mean, this is a simple example, and clearly.
Yeah. It's,
like I said, though, you can actually use both. And if we put this back in here, so we've now got this one side by side.
Yep.
We need to set the data context, which we can do there. And actually, here's a neat trick as well, which is what this other bit of commented out code was about. Instead of newing up a view model and doing it like that, instead you can hook the data context changed event on the page. So it means whenever you set the data context property of the page for classic binding purposes, it will automatically, this anonymous function here, it will automatically change the view model property to be equal to the data context, which we know is a main page view model. So effectively we reset the value of that property every time the data context is changed. So you can actually combine the two worlds there. So and sometimes you're going to want to do that. And just to prove we haven't broken anything. Yeah, there we go. Real good. So yeah, that's just to drill home those syntax differences. You can see there, binding items, you xbind to view model.items. You have to put the data type onto the data template like that. Yeah. And in general, this is a good tip. Obviously, obviously, other things you can do for important. Xbind is a great step forward, as you saw from those graphs before, good CPU and memory. But actually, just obviously keep your templates as simple as possible. Use xphase, like you were talking about yesterday, and use deferred binding.
Xphase is the wonderful thing, yeah.
You can also use xbind inside resource dictionaries, but it comes with a little interesting kind of side effect, is that resource dictionaries are just XAML files containing resources, definitions. You could put data templates in them, give them a key, styles, anything can go into it. It's just a dictionary for collections of bits of XAML. Now if you use, so you can define it, here we've got a data template called my template is defined in here, but you've got to add a code behind now to your resource dictionary, because this is compiled. So you've got to call this initialize component in order for this to get compiled.
Otherwise, it's just
otherwise it's just XAML.
It's like a text file, I suppose. It never gets.
So for this to work, you've actually got to add a code behind to your resource dictionary, like that, and you give it. Obviously, you've got to give it a class name. It's got to have a code name. So this name is my namespace.mytemplate. So it's now just the same structure as a XAML page. In fact,
but the key thing here is it's not deriving from page or any of the other types that you can control. It's literally just a class.
It's just a class,
so
and then when you want to refer to that, you can just refer to it just the same as a static XAML thing. Just you create an instance of it and stick it into your merged dictionaries like this, and now you've got access to all of those resources throughout your application or wherever this happens to be. This is an example of user control. Here's a nice thing as well, actually compiled bindings. If you can do one time, and if you want to programmatically force the update to happen, actually all you can do is now there's a property called bindings and it's got an update method on it. So instead you could actually, for additional perf improvements, you could have all of your bindings xbind to be one time, and then whenever you've done if you know that when the data is going to be updated, you could force update on all the bindings just by calling bindings.update.
And is that on everything, or can I be specific and say, actually I just want this property to
No, it's just across the, it's on the page of the object, wherever you declare that. Yeah. Here's another interesting thing as well. You can actually bind to events as well. So you can xbind a click event, xbind to an event. Now, we've always been able to do this with MVVM using iCommand.
Yeah.
And iCommand's very sophisticated. But actually, so you can bind, here you've got click xbind employee.poke. You can actually put the event handler into your view model.
Nice. You
can either say no parameters, that's valid. You could match the event parameters of the click event as if it was a normal, on-click event handler. Or if you got, event handlers are in a hierarchy, so you could simply match the base event handler class and just
like a catch-all.
Yeah, so your event handler in your view model could be object sender, objectee, but overloading is not supported. And you can use any events are eligible for this. And actually, it might replace iCommand, which is this sophisticated pattern that we've been using up till now in event to command. iCommand comes with some other interesting things, like it can
execute and things like that.
Yeah, it has all sorts of other things. So you can actually you can bind a button to an iCommand, and in your view model you can sort of change the state of that command to say it's valid or not valid, and your button will automatically enable or disable. But so you can't do that with this. But this is
a lot easier to get it.
And this iCommand's really verbose. You end up with this big block of code.
Yeah.
So that's really nice. Yeah. So yeah, it doesn't include a parameter or can execute. And you can also pause compiled bindings updates as well. So if you've got like one-way going or one-way binding or two-way binding, you can actually call bindings.StopTracking at any point.
So when would this be useful? Is this useful when I've got maybe too much happening or not enough happening, or what's the?
Yeah, I guess yeah. If you know you're going to do a lot of updates and you want to update the UI all at once, you can just effectively pause the updates and then re-enable and then do bindings.update, boom, and cause it to.
Or just like wait for a quiet time and then say, right, now's the time to release the.
Now, I think how do I's. If you want to actually go to an element name, I already talked about this. Another element on the page is just a first-class property of the page anyway. So you just xbind to it.
Okay.
You cannot use xbind in control templates, but template binding is already pretty optimized in there anyway.
Yeah.
And the last one, this thing about the source and data context, how you marry them. Well, I already showed you in that demo. You can just add a view model class to your code behind and use that pattern. So that all works pretty well. So there's that pattern that we just talked about. The data context change is a nice way of combining the two worlds. So that's what we recommend you do in order to get this thing. It's very good, and we're still working on it. It does cover most of the situations you want, but there's a few things where it doesn't work.
Preempted my next question.
Yeah. So when would you use classic binding? Well, actually, you might want this kind of this duck typing. Maybe you want to take advantage of that. So obviously, clearly like that. If you've got sort of JSON objects, you can actually use classic binding with that, and it will just go and drill down to the top level elements. But that won't work with xbind. So that's what we call dictionary graphs. You can add and remove xbind at runtime, but I should say can't add and remove xbind at runtime. Sorry,
that's a new feature you're adding.
I know to fix that slide. Can't add and remove xbind at runtime. So you can actually obviously do more of that code behind binding with classic. And you can't use xbind in a style for setters. Although, as we've shown, you can use it in a data template. Yeah. So, in summary, xbind can meet your binding needs most of the time.
And then the nice thing is, it's not like it's one or the other. You can do xbind to an extent, and then when you feel like, hey, I can't use xbind here, you can just drop back to classic binding.
Yep,
so you're reaping as many benefits as sort of possible, but you don't have to sort of say, I'm going to put all my eggs in the xbind basket.
No, that's right, exactly. But yeah, for anything that's got even a moderately complex UI, xbind can give you a good performance boost. Yeah. Cool. So there we go. That's what we looked at. We took you through data binding basics and a good run through all of that compiled binding stuff. We're going to take a 5 or 6 minute break now. We'll be back at the top of the hour for background tasks, execution stuff. So we'll see you then. Thanks.
Thank you.